All right, good afternoon, everyone. I'm Kai Horstmann. I'll be talking about Java for small coding tasks. If you want to have a copy of the presentation, you see a URL at the very bottom in tiny writing, horstmann.com/presentations/2025/JavaOne. You might want to snap a picture of that. There's a bunch of links in here embedded in these slides that you might find useful. All right, so just a couple of things about myself. My claim to fame is that when Java first came out, Gary Cornell and I wrote the first real Java book called Core Java. It's now in its 13th edition. I'm working on the 14th edition for Java 2025. I've written a bunch of other books. My publisher wants you to know that there is a conference discount for those books that you can find by clicking on this link if you do download the slides. All right, so right on to why do we care about small Java? Of course, we all know that Java is a fantastic programming language for big iron projects, but why do it for small programs? And so I got into this because I'm in book publishing. I do write a lot of scripts that get information from here to there in this format, in that format, whatever. And of course, I write those scripts like any right-thinking person would in Bash. And then I come back to the script a few weeks later, and it's not really doing all of that great. Another thing that I sometimes do in Java, actually, is I want to just explore some new API because I want to explain it, and those programs are also kind of small. So yeah, why do I like to use Java? First of all, of course, because it's familiar. And I think that's also, if you are thinking of automate something small in your own company, that's an actual asset. You might so far say, oh, this is kind of small, so Java might not be the greatest thing. I'll do it in Python or in Go or whatever. But then when you need to do code review or something, then you need to have someone who's good at Python or Go or whatever, or God forbid, Bash. The other reason is I've done this for many years, and I take great joy in the fact that I can take a script that I haven't touched for 10 years, or 15 even, and it still works the same way that it always did. That stability is great. I don't personally have this use case, but the first time I gave this presentation, someone else said, this is what I've been doing all this time. I'm glad I'm not the only one, because that person said, I'm using Java because it's portable. And I said, what do you mean? Bash is not portable? He said, to Windows. So that was his use case. Another reason that I like Java over some of the alternatives is it's compile time typed. I'm not very smart. I make a lot of errors. I like the compiler to find those errors for me before I have to debug them at runtime. And of course, Java has a vast ecosystem of libraries out there. And it's also a high quality ecosystem of libraries. There are other programming environments that should not be mentioned, such as Python, where you always have the choice between 10 different half-assed implementations of something, whereas in Java, there's usually one that's really good and not too many choices to make. So yeah, so why not shell? Shell is, of course, super nice when you do it the first time and you just need to move things from here to there and maybe do a small transformation. But then life intervenes and your process gets more complicated, and so you patch your shell script and it still works, and then you look at it 6 months later and you say, what is it that I just wrote? And after 10 years of that, you have an absolute unmaintainable mess. I have those things on this very laptop. You know, why not Python? I mean, Python is a fine language for scripting, but it's not compile time typed. It's also, I don't know it quite as well as I know Java, which you might be in the same boat. And also, like I said, quality of libraries is not necessarily, and the quality of tools in Python, I mean, really, have you seen some of them? I used to do a bunch of scripting in Scala, because Scala was explicitly invented to be this scalable language, right, from the smallest script to the biggest program. And I enjoyed doing it as an intellectual exercise. But then when I now look at a script that I have that was written in Scala 2, and now Scala 3 is there, and also, of course, I tried to be too clever, and I can't read the script anymore. So Java turns out to be, for me, a sweet spot. And I've talked to a whole bunch of other people who seem to feel the same way. Now, one of the rules of this game for me is I will not use Maven or Gradle because then the cost of starting up is too high. When I have the first time I look at some task, and I already need to make myself do it in Java and not in Shell. And if I then have to do source main Java and a POM file, then I'll just go back to shell, and then I regret it years later. And so these are, of course, wonderful tools, but they may not be, the bang for the buck just isn't there for small programs. So I'm giving this talk now because Java has had some recent changes that make this whole thing actually a lot more attractive. So there's a couple of JEPs that do this. And so the first thing is you no longer need to run Java-C. Now you might say, why does anyone care? I mean, how hard is it to run Java-C? But Java-C has one disadvantage, namely it clutters up your directory with these unpleasant class files. Whereas if you just use Java, then the compilation goes on in memory, and it just executes what is compiled in memory. Now, you might say that's super wasteful. Every single time your program gets compiled, but you know, in Python it's no different, and people live with that. So note the extension .java. So there is no class files. You simply execute the Java file, and it's kind of pleasant. You can also, if you don't want to have the extension .java, and there's no particular reason maybe, if you don't want to launch it like this, if you want to launch it in a very shell-like way, then you can also make the first line of your program be a shebang, and then you can start the program by just giving the path. There's just one thing you can't do. You can't then give the file an extension .java. And that's a bit of a pain, because when you make the first change to your script, you would like your editor to realize that it's a Java file and wake up in Java mode. So that's not so wonderful. And so the remedy is simple. Instead, you use a different shebang, the one that you see. Oops, I'm supposed to leave this area here. You use a / user bin env Java, and so that way the shell will think that this thing just runs Java, and Java itself will think it's a comment. Extra credit for anyone who, after the presentation, can tell me why there's 3 slashes and not 2. So I'll just demo this here. Just really quick so that you see something. So I have one such script here. Let me make this a little bit bigger here if I can. There we go. So now it's going to be running the script. This script here is something that is a part of my backup procedure. So I back up my laptop once a day. And then I randomly pick 10 files out of my file system. And then I verify that those 10 files can be properly restored. So it's nothing much. We can have a quick look at the script here. Again, let me make this a little bigger. And so I'm not really going to show you anything. It's just Java. That's all I want to show. And obviously, you can program this in Java. I did program this in shell before, and I couldn't understand it. The next thing is recently, to pave the on-ramp for beginning learners, a couple of JEPs came out that make it easier to write Java programs. So you no longer have to have public static void main string bracket args. You could just have void main. And yeah, you can still have public protected static whatever, but there's no reason to. And more importantly, you can also omit the class if there's only one. So if your file has a single class, you boldly go and omit the class, my class, and whatever you have left over is now your program. So your program looks like variable declarations, some method declarations, and at the very end, or anywhere really, you have void main. If you need args, you put them in. If you don't need args, you don't put them in. And so your program looks simpler. Of course, these variables are actually instance variables of some class. That class has the same name as the file name, which is a .java file. And so the variables become instance methods. Instance variables, the methods become instance methods. But you don't normally have to think about that. Also, there is kind of a nifty I/O class that gives you methods println, print, and readln. So you no longer have to say system.out.println, but you can say io.println. And what's not to like, right? 7 letters fewer. And the killer feature is when you do this anonymous class, then you also get a magic import that we don't see on the slide. Let me scroll this, sorry. You get a magic import of the entire Java base module. So all of the packages in the Java base module have been cunningly named so that there are no naming conflicts between them. And so you get the whole thing imported. And so you no longer have to worry about importing like Java util dot whatever. So that's nice. It gives you the whole thing kind of a Pythonic vibe when you program. So you feel like you're programming in a kind of scripting fashion, even though it's still full-blown Java. So I found that very liberating. So I'm just going to just very briefly demo one, just show you how one of these looks like in the wild. Again, the content doesn't matter, only the shape of the thing matters. Now, let me. So here you see a file that actually has a little record in here. It has a couple of instance variables. It has a bunch of methods. And it just goes on and does something in Java. What does it do? Whenever I have a Zoom call anywhere in the world, I run this script, and it automatically figures out what speakers, what headphones I have attached to my, my laptop, and it switches to the right one. And then the kind of thing that you think that Zoom should be able to do for a living, but it can't on a Linux system. All right. So, and you've seen the thing start out with a record. And so when you do this programming in the small, records are kind of your friend. They're very easy to write. And they are more explicit than what you would do in Python. So in Python, you commonly have these kind of ad hoc lists and maps, or dictionaries as they call them. And you kind of have to know from context what they are. In Java, you give everything a name, and so you can tell. This here thing had nothing to do with anything important. This was from the last advent of code, where apparently some puzzle had a brick. And you can see that this thing expresses bricks. And you can see what those things are. They're the top left and the bottom right corner of the thing, instead of just seeing these dicts with X and Y. And you get free methods, and just the kind of methods that you need if you want to collect some of them, if you want to do equality testing. And also, what I then find is that it gives an easy way of adding helper methods. They just slot into the right spot. So here in this advent of code problem, I needed to parse a brick from input. I needed to test whether 2 bricks overlap. And they just become natural methods of it. And so even though I said, you don't need any structure, you just use a single class, I lied. You actually have a few mini classes, namely these records. And so it kind of naturally develops like that. If we go back here, over here, I have like a little class for an audio source and sync. And it has a couple of properties. This one doesn't happen to have any methods, but maybe it will next time that I revise the script. So the reason that records are kind of superior to just using ad hoc dictionaries is the names are good. And for the same reason, in Java you have enum. Enum gives names. Enum gives maybe a home for methods. And so those are kind of good things. A few other helpful language features. First of all, compile time typing really is nicer. So if you look at the first line of code, which is recognizably Java, and you can kind of see what this thing does. If you look at the second line of code, you can also see what it does because there is a helpful comment explaining it. Notice that the second line of Python is longer than the first line of Java. So it's not that Java is necessarily any less concise than Python. Another nice thing is, don't fear static imports. You can already, with the importing of all of Java base, you can get rid of a lot of noisy imports that is kind of pleasant. But also, I always feel people kind of underutilize static imports. But for a large, when you have a big program, you might not love static imports because you're worried about conflicts. But for small programs, they're not usually a problem. And they make your code a little bit more concise to read. Of course, var is your friend. Again, in a big program, you might say, do I really want to use var everywhere? It makes the program less readable, and someone else might read it and find it confusing. For a script, maybe that is not there so much. So I tend to use var more liberally than I use when I write something bigger and more solid. Same thing with the diamond notation. I kind of use it more aggressively in this context. Textbooks blocks are your friend, because sometimes you have like some data, some configuration data, and in a bigger program you would put it wherever you put your configuration, in an extra file or who knows where. But with a small program, it's kind of nice to keep it right in the code, because that way you have everything in a single file and you don't need to hunt for that extra configuration file when you open that script years later. It's kind of like a here document in Bash. And so the text block syntax is perfect for that. So, of course, for ad hoc lists and maps, there's list.off and map.off that are nice. And so like a little tip. So I used to say, well, I'll start out with an array when I know that something is never going to change. And I've made the painful experience that these things always change. And so here you have the seasons. Well, that's a silly prejudice, because your customers on Mars are going to have the 5th season, and so then you would have to change it. And to refactor from an array to a list is painful. So I've learned you just always use lists. There's no reason ever to use arrays, except, of course, for the args. Right? You have no choice with args. That's handed to you as an array. And OK, there's a few times in the API that you get an array. But if you look at the modern API, that's less and less. Most of the things these days are given to you as lists. Also, sometimes it's kind of useful to use map, filter, count, collect with streams. They can make your code nice and concise. So the Java language has some pleasant features for writing small programs. And the Java API actually does as well. So if you look at the library, strings, regex, collections, date and time, the Java standard library, what's in there, batteries included, is really, really good. If you compare that with what you get from other languages, you just get the good stuff right away, and you don't have to hunt around for it. For I/O, some people saying that I/O in Java is cumbersome, so there's still some people who program with buffered reader in 2025. Don't do that. The new I/O, new is not really very new, right? It's 20 years old or so, which you should never name an API new. And so in NIO, you can read a file with a single line of code. You can read lines and so on. So just do that. So I/O in Java, I think, is first class. I've had to do I/O in Python, and the grass is not greener on the other side. It's not that Python is terrible, but it's also not magically good. Streams are nice as long as you use them with restraint. It is very easy to write very convoluted stream code that you can read 6 months later, and that's not the point of the exercise. So Java has a processes library. It's fine. It has an HTTP client. It has 2 HTTP clients, in fact, right? The old one and the new one. And it now has an HTTP server, and they're OK. Certainly battle tested, nothing wrong with it. There is XML. I have to do a fair amount of XML, and I think serviceable describes the quality of that library. There's 2 things that are missing in action. JSON. I really wish there was JSON in the Java API, because it forces you to get JSON from somewhere else right now. And the other one is command line arc parsing. And with the kinds of tools that I'm talking about, it's very common that you have to add command line arc parsing. You can do some of it ad hoc, but pretty soon that gets to be unfun. And I think those are 2 things that really ought to be in the Java API, just in case there's anyone from Oracle around here. So that brings us to the issue of what do you do about Maven? So JDK knows nothing about Maven, right? There's no one at Oracle who's ever heard that such a thing as Maven might exist. And so sometimes when I just say, OK, I just need a single thing, then I sometimes hunt for a library that does that one thing in one file. So I've given you links to two libraries that one of them has just some dead simple JSON implementation in a single Java file, and then I put that next to my other single Java file, and that kind of works. So I could demo that, but I think in the interest of time, I'll skip that. You get the idea. And so this particular JSON library is very endearing. It's not like a big library. It doesn't do any. It can't transform arbitrary types, but it does sets and maps, just arrays and maps, I should say, lists and maps. That's fine. But of course, at some point, there is some actual library that you want to use. And there are a couple of tools that let you do that. So there's a tool called JPM, and I'll just you can just see here what you would have to do. And actually, I'll just do this real quick so you get a feel for it. Okay, let me this one get a little bigger. So let's see. Over here, so I'm going to remove this depth library here. RF, come on. And so now I'm going to run this JPM install thing, and you'll see what it does. So it'll now go to the internet, and it has now downloaded this jar file. And it can download dependencies as well. And now I can go to town and run my program by just including this class path here. And I'll just do this so that you see some awesome scripting in action here. I don't even know why I have enabled preview. Ah. Sorry. So here's one problem that I can't autocomplete in Bash because Bash doesn't know about autocomplete of .java. Oh, because it's an unnamed class. Of course it is. Yes. This will hopefully go away in Java 25. What is it? Source 24, and now it's gonna say I don't have just okay SDK. Use Java 24. I should have made this automatic. Oh, because yeah, there we go. Ta-da. Okay. All right. So that's why we needed to have this library. All right. So and this works. These two approaches are possible solutions. The more professional way is to use JBang, and I'll talk about JBang soon. Another thing to just ponder a little bit about is checked exceptions. It's a bit of a pain that checked exceptions are heavyweight in scripts. You have to put all these throw specifiers there. And in a script, oftentimes you don't really care. If the script just terminates with a stack trace, that is a lot better than your standard Bash script, which just keeps on trucking. And then I do what my students have taught me. You simply add throws exception at the end of every method. Right? That's a perfectly reasonable strategy, even me. Now, if anyone from Oracle is listening, wouldn't that be nice if this was the default in the unnamed class? Right, just like we get all of Java base for free. This would be a nice on-ramp to exception handling if for very simple code, one didn't have to worry about checked exceptions, and then once one adds it into a regular class where one also has to start worrying about imports, then maybe the checked exceptions should come in. Just saying. It's still painful in Lambda expressions. Right here, I am having a bunch of files, path names, and I want to map read strings so that I read them all in. Can't do that because that thing throws an I/O exception. So is there any way not to do the painful thing that you see in the next line? So there are a couple of libraries that exploit some type holes. And so if you've never seen one of those, go and get my slides and click on this link. They're usually called sneaky throw or something. And so you cleverly wrap the lambda with one of these sneaky functions. And then they will absorb all the checked exceptions. And they will not actually turn them into unchecked exceptions. They're still checked exceptions, but the type system no longer knows about them. So, I mean, I would never do that. That's just asking for a friend here. But in a small script, I think that might be defensible. In a large program, you would, of course, never want to do that. So file organization. Like I said, I really do not like to have my already cluttered up file system now already cluttered up more with source main Java directories. And so you could say, well, it doesn't really matter, right? I could just put my myscript.java into wherever is a natural home for it, and then I just use VI to edit it. But if you use a bare bones text editor, that's not so much fun because you do kind of like, auto-completion, instant error display, API lookup, that kind of stuff. So one solution is to use a middleweight code editor, such as Vim or Emacs or VS Code. They have enough Java support that you can load any file right into the editor without having to first make a project, and you get these kind of comfort features okay. So I think in the interest of time, I'm not showing you how this looks like. Well, actually, I have VS Code running here, so we can just have a quick look at it. So here's VS Code, and so it loads a single source file, namely that audio file that you've seen before. And how can we tell that it actually is working? We can see because VS Code has put the run and debug annotations here over main, so it knows everything about it. You can also see that there's a few names of parameters, so it has looked those up in the Java API. So it looks like normal. And you could now actually go and, on a good day, debug with it. And VS Code is what it is. As they say about the dancing bear, it doesn't matter how well it dances. It's amazing that it dances at all. So, of course, you might want to use an actual IDE. And so in the past, it used to be, if you tried to get IntelliJ to not have source main Java, that was, you could fight it, but it was pretty hard. The latest version of IntelliJ somehow has made this easier. So I discovered to my delight that I can actually, as long as I put a Java file into the base directory without source main Java, and then I tell IntelliJ or Eclipse to make a project in that directory, when they don't find source main Java, they cry a little, and then they make a project that doesn't have it. But that only started working really recently. In older versions of IntelliJ, one has to fiddle with the project structure, and there's some instructions here that if you still use one of these older ones, that you could do at home. All right, a couple of other things that you might want to explore when you write these scripts. Should you use Graal? So you can. Of course, compile your Java program and then use Graal native image to make it into a native program on your platform. I've done that with one thing. I've always had a little bit of envy. People showed me these tiling window managers, and I said, well, that's too much for me, but it would be kind of nice to have something in my Linux system how I can arrange some of these windows. So I actually did a script where I can resize these windows and move them around and whatever, and it's written in Java. And I said, well, maybe it's too slow when I don't compile it. And in fact, it is slower. So this is the kind of thing that Graal will speed up. So if I just, so you can see here, it's 4 times faster than if I run Java and have it compiled. Probably it doesn't really matter for this thing, but there you have it. The executables aren't small, but still, it could be an option. And it really is pretty easy to do. Some people say, well, why are you not simply using JShell? Is there anyone here who does not know what JShell is? That's good, because sometimes people, when I give this presentation, people say they've never heard of JShell. So I do use JShell all the time for like little experiments. I have, over the last year, monitored my JShell usage to find out what I actually use it for. And the sad thing is, of course, that 90% is to fuss with regex. So, and it's really good for that, right? So here is one of the regex from that audio program where it parses out something that comes from running something. And of course, I got the regex wrong the first time. And then I paste it into JShell, and I see what it's good for. But that's not really scripting. Now, if you want to experiment with a new library that more likely than not is not a library in the JDK, which we all know, but it's probably a third-party library. And you can actually use that very same JPM thing that I showed you before that fetches arbitrary stuff from Maven. You can also use it to fetch it, and then you start JShell with the class path from that. So here's something that you could try at home. You could make yourself a little program that uses this table saw library. It's a data frame library that can read CSV files and then show them in tabular form and manipulate them. So if you want to try that, go for that. Of course, JShell can be pretty awkward with longer code. There is a way of saving your snippets and reloading them, but it's not super elegant. Some IDEs include JShell, but unfortunately, I have not seen an IDE that does a really good job. You would think that an IDE could do a bang-up job with JShell and give you autocomplete debugging and everything, but they seem to view it as a poor cousin or something, and I have not yet seen that. I'll talk a little bit more about that. Now, one could use JShell for scripting. It is possible to write JShell scripting, but Brian doesn't like it. And so I haven't really done it. And ultimately, there's no advantage of using JShell over using just straight old Java. And with Java, you then have the path to have like a real debugger and to have actual tools and things. So I'm not recommending it. So if there's only one thing that you should learn from this talk is to check out JBang. This is not a JBang talk, so I don't want to extol all of its features, but just the basics. So JBang is a tool that it's an open source tool that can do the same thing as the Java launcher can do, but even with Java 8. So you can use it to launch Java files without compiling them. It will compile them in the background. And the killer feature of JBang is it will handle Maven coordinates. You simply make a sudo comment //deps, and JBang will read it. It will fetch the files from Maven and put them somewhere. And so that really is it's worth its weight in gold. You can also have compile options and runtime options with these pseudo comments. I think that's super smart and elegant, and so I highly recommend that. And then it has like a lot of nifty little things that otherwise in Maven you would have to do whatever you do. Like for example, to make a fat jar. There you see how to make it. You can make a native image. It has templates for basic things. Like here, when you say CLI, you get the command line handling with Pico CLI. You can launch JShell with the dependencies in place. So that way you don't have to do the thing that I've just shown you with JPM. You can launch an editor of, for example, IntelliJ in a sandbox so that the symlinks forced what the IDE will then perceive to be source main Java. It's all set up so that the IDE thinks that you're having a full-blown project when in fact all you have is a single file. So super nice. You can even launch a debugger, and there's tons more. So absolutely go and check out JBang. If you can use JBang, that's the single easiest entry point to using Java in the small. Some people tell me for whatever reason they can't really use it and they have to rely on some of these individual strategies, which is why I've started out with them. But it is a batteries included solution for a lot of these things. So that's what I wanted to say about how to do basic scripting. And the other kind of scripting that I've now see people do more with Java is the kind of notebooks style scripting. And so that's different. People use a notebook because they want to do interactive programming, something explorative. So it's more on the JShell thing, but it's more permanent than JShell. JShell is very throwaway, right? You try something out, and then you never use it again. You would use a notebook because you want to explore something, and then you want to communicate. You want to share it with other people. And so, of course, so far you've seen those in Python. You have code cells, you have outputs, it's visual, graphs, tables, and so on. And you can also put in markdown comments in there. And you can either run it locally by running Jupyter on your own machine, or you can use Google Colab or a similar service. I think Colab is by far the smoothest of the ones to use. And then multiple people can collaborate on the same thing. So that's very nice. But of course, it's in Python. This project here has made it their mission to make it so that you can run Jupyter notebooks easily in Java without having to think too hard. So it uses actually JBang to install a Java kernel for the notebook. And so this is the basic code that the Jupyter Java Anywhere project says that you should try out. So you install JBang, then you install this kernel, and then afterwards you are in the world of Java. So let me just demo this here. So let me go to my this is too big. Oh, squiggle. So this will start up the Jupyter Notebook server. And I will be running this program here. So you can see, obviously, this thing here is not Python. It is plain old Java. It has double stream, and so on. And so this one here, I have installed the Java kernel, and we could just run it. But it's more convincing to see this when I put it into Colab. So let me do that. So here, we're already in Colab. So I've gone to their starter thing. I have, in the interest of time, installed the kernel. Now I need to switch to the kernel. So, oh, it already has it. That's nice. And now we can test that it works. I am not sure it works because it says system is not defined, so I may need to.
I think it's just without the system.
I'm sorry?
I think it's without the system.
No. It should work. But it's, I don't think it has the, maybe because I did it too long ago. That is the disadvantage of this approach with Colab, that it does take a bit to reload it each time. So let's see what the kernel is. Runtime, switch runtime. Yeah, change runtime type. Yeah. Okay, maybe it was the wrong runtime. Okay, well, that is the disadvantage of demoing it with Colab. It is not always. So we may come back to it. So the point I want to make is that with some amount of pain, you can install a Java kernel, and then you can do this kind of computation in Java. There was a talk yesterday that went into much more detail with that, and so you might want to get the recording of it. He had more time, and he also had the wisdom of setting up a Docker container so that everything ran a little more smoothly. All right, so what happened to my presentation? I don't know.
It looks like it finished. Yeah, it worked.
Oh, yes, thank you, yes. So here you can see that it did manage to handle system out println, so it was actually Java. And so you can do this. The unpleasant part is really in Colab that you have to do that installation every time. I've talked to the Colab people about it, and they said, oh, this is actually kind of cool, and maybe eventually they will give us a thing that natively can handle Java. That would be wonderful. All right, so let me reload my presentation, which seems to have gotten lost. Okay. All right. So we've done this. We have a demo. We've had a demo of Colab. Now, of course, Jupyter notebooks work very well with Python, and the Java support is a little rough. The first thing that I noticed is that, so I said, oh, I need a Java kernel, and now I'm in this situation in Java, where instead of having one good kernel, there are 4 of varying qualities. The Jupyter Anywhere project uses JJava, which I have found solid. Supposedly, these other kernels have some other advantages, and we're not entirely sure what they are. And it's disturbing that there's more than one. The old one, the iJava, is just old and obsolete. But that's the one that comes up first in searches. Now, what do you do instead of NumPy? You need to have some kind of a data frame library. So I've found several that I'm not an expert, that seem to work, and for my simple cases, they all did work. There is a talk on data frame libraries, I think in this room at 2, by people who know much more than I do about this. So if you're interested in this, by all means, stick around and listen to them. What about plotting? Well, in Python, we have matplotlib. Matplotlib may not be God's gift to API design, but it is widely used, and your chatbot of choice will know how to take your data and plot them more or less the way that you want. In Java, there are some libraries that some of them look easy to get into, some of them look pretty sophisticated, but there's no one that's standard, so there would be some experimentation involved to see which one works for you. Another thing is, it's kind of weird with Jupyter that it runs in the browser, and if you run it locally, wouldn't it be much nicer to have an app? Well, there actually is an app. Sven Reimers and his collaborators have produced a JavaFX app where you can run notebooks locally, Java notebooks locally, and it's very nice. And it's the one game in town. And so if you're interested in this, and also if you have other ideas, people have approached me saying, wouldn't it be nice if we could do this or that? And my answer is go to Sven and tell him that this would be a really good idea. And so he really is committed to building this thing out to be good. So I'm going to run it in a minute, and you can see it. I'm running it here from the latest release. I'm using Gradle to start it up. It is not a small program. And so here it is. Let's just load a file. Make it a little bigger. So I don't know how to change font size. It's too new for being able to change font size. And so now I can run it, and you can see it has Java code, and it does what a notebook should be doing. Notice that to add some other Maven stuff, it's a little bit different. It doesn't use the magic style that's used elsewhere, but it uses this format. But it's nice. All right. So IntelliJ does support Jupyter notebooks, and it's pretty good, but unfortunately only in Python and Kotlin. So if you know anyone from IntelliJ, you might ask them, why don't they do that in Java? And they really should. Now, notebooks are not the perfect thing. They could be better, although the implementation in IntelliJ is pretty good, and JChaquino could get better. But there's things that one might want to rethink. Do you really need exactly the kind of notebooks that they have in Python? And so I don't want to go too much down here because we're just about out of time. But there are other people who come up with new and creative ideas. And I think right now is the time in Java to do just that. Now, what do we really want? We want to edit Java code. We want to have this fluid experimentation style like we have in JShell. We want to have that to see the input-output explanations like in a notebook. That's really cool. You, of course, want to have debugging, AI code assistance, and all of that good stuff. You want to have that in a single interactive exploratory tool in Java. And we're not that far away from that. So I would watch that space, look at the usual suspects, and see what we're going to be getting in the future. I think the Java space there is right now in a point of vibrancy. So in summary, what I want you to come away with is that Java is actually non-bad in the small. It greatly exceeds anyone's modest expectations. It really, I think you will enjoy using it. And there's some real advantages to using it. And the first one is, the tools are good. And they're good. The tools are good because Java has compile-time typing. So Python will never be able to be as good as that as Java is. And so you might as well then move to Java. The standard library is good. The language has always been good. And recent features focus on this use case and make it even more pleasant. It's portable. Yeah, there is currently this weak point of third-party integration that Maven is not really part of Java, but there are tools that make that actually perfectly easy. So it's not a pain point in practice. It just would be nice if in the future, we could get all of this just with the JDK. But so far, there's JBang, and so that is your tool of choice to bring this to easy and painless resolution. Yeah, and watch out for notebooks. And I didn't get to that slide. One day, we may actually have a resurgence of Java running in the browser. That would be another kind of programming in the small. And maybe I can do that next year at JavaOne. That's pretty much all I have. Thank you very much.